Hello everyone, welcome back. In today's lecture, I'll be explaining about the limits of fit. Now, in previous lecture, I explained about the interchangeability, then the important terms used in limit system. After the important terms, I explained about the fit. There were basically three types: clearance, interference, and transition fit. And there was basis of limit system. The what were the two basis system? Whole basis system and shaft basis system. Now in today's lecture, I will further move on with the basis of limit system. So here in the generalized diagram, you can see the whole basis and the shaft basis system may be shown in the figure with respect to zero line. It may be noted that from the manufacturing point of view, a whole basis system is always preferred. This is because that the wholes are usually produced and finished by standard tooling like drill reamers whose size is not adjustable easily. On the other hand, the size of shaft which is to go into the hole can be easily adjusted and is obtained by turning or grinding operations. So why we are using the whole basis system most preferable because of whole bases are usually produced by the standard tooling. So whole basis system is not generally whole basis system is mostly preferred instead of shaft basis system from manufacturing point of view. Okay, so keeping this zero line for the both the system, the half portion over here, this is the shaft basis system, and this half portion over here, it is the whole basis system. The first kind of fit is the clearance fit. As you can see, the difference between hole and shaft, and there is the transition fit, and there is the interference fit as the shaft size is large. Similarly, the first one is the clearance, transition, and interference fit. The next topic is Indian standard system of limits and fits. Now, there are certain specified standards for limits and fits. So, according to Indian standard, this is the code for the same. The system of limits and fit comprises total 18 grades of fundamental tolerances, grades of accuracy of manufacture, and 25 types of fundamental deviations indicated by letter symbols for both holes and shafts. Capital letter A to ZC for holes and small letter A to ZC for shaft in diameter, steps ranging from 1 to 500 mm. Now, what it says, how many standards are there? There are total 18 fundamental tolerances. Tolerance, which means the given to the single part or hole or shaft, either. Okay, so tolerance is always positive. Then the fundamental deviation. Deviation means that the like, type of fit means clearance, interference. So there were total 25. Now let us discuss about the uh, 18 grades of fundamental tolerances, and they are fundamental deviation by indicated by letter A to ZC for hole, and for shaft we use the small letter A to Z, small c, and the diameter steps in the range of 1 to 500 mm. A unilateral whole basis system is recommended, but if necessary, a unilateral or bilateral shaft basis system may also be used. The 18 tolerance grades are designed as IT01, IT0, then IT1 to IT16. So the remember this. First thing you need to remember that the unilateral whole basis system is always recommended from the manufacturing point of view, but sometimes if it is necessary that the unilateral or bilateral shaft basis system is needed to be used, then also we can use. Now the 18 tolerance grade are remember that the first two are IT01 and IT0. Then it starts from IT1 to IT16. So 16 plus 2 it is 18 number of tolerances, and these are the fundamental tolerances or the standard tolerances. Now the standard tolerance for grades IT5 to IT7 are determined in terms of standard tolerance unit I in microns, where I microns means 0.45 under root cubed root of d plus 0.001 d, where d is the size or geometric mean diameter in mm. Now this fundamental deviation is for IT5 to IT7, which means IT5, IT6 and IT7 we can have the value of the standard tolerance in micron using these equations, which means based on the diameter you can find out for these standard tolerances. For now, the following table shows the relative magnitude for grades between IT5 to IT16. So here let us see for IT5 to IT16 the magnitude of is given by 7i, 10i, 16i, 25i, similarly up to 1000i for IT16, and the value of standard tolerance corresponding to grade IT01, IT0 and IT1 are given in the below, where I is equal to micron. For IT01 it is zero point 0.3 plus 0.008 D. For IT0, I micron is equal to zero point 0.5 plus 0.012 D. Then IT1, it is I microns is equal to zero point 0.8 plus 0.020 D, where D is the size or geometric mean diameter in mm. Now you can remember basically for 01 it is 0.3.008, then zero point 0.5 means plus 2.02 increment, or then on the other hand there is the zero point 0.4 increment, and here again zero point 0.3 increment for the third one and zero point 0.8 increment over here. So the tolerance value of grade IT2 to IT4 are scaled approximately between the IT1 and IT5. They are approximately selected, the IT2 to IT4. Now for hole, capital H stands for a dimension whose lower deviation refers to basic size. The whole capital H for which the lower deviation is 0 is called as the basic whole. Now what is the basic whole which the lower deviation is 0, that is the basic whole. And for whole, capital H stands for the dimension whose lower deviation refers to the basic size. Now similarly for the shaft, small h stands for dimension whose the upper deviation refers to the basic size. For shaft, it is always upper deviation. that is the basic size. For hole, it is the lower deviation, that is the always basic size. The shaft edge for which the upper deviation is 0 is called as the basic shaft. The shaft whose upper deviation is 0 is called basic shaft. A feet is designed by its basic size followed by symbol representing limits of each of its two components, the whole being quoted first. Now, how it is designed fit by its basic size, followed by symbol representing the limits of each of its two component and whole being quoted. Now, for example, 100 capital H6 G5 means that the basic size is 100 mm and the tolerance grade for the hole is 6 and for shaft it is 5. Now, how to decide 6 and 5? That is from here we can use the IT6 or IT5. So for IT6 the equation is the 10I and I is equal to 0.45 cube root of D plus 0.001 D. Now you can use this equation and put the value for IT5 it is 7I, then put the value 100 in this 100 mm over here. So you can get the cube root and multiply with the zero point 0.5. So you can get the micron value and multiply it by 7. So you will get the tolerance for the capital H, which means the for the shaft, and small g, which means for the hole. Sorry, for the shaft, and capital H means for the hole. Now, after this Indian standards for standard system for of limits and fits, we will move to the next topic, that is about the geometric tolerances. In certain circumstances, tolerances of size, which was discussed in the previous point, are not sufficient to provide the required control of foam or not sufficient to ensure the acceptance of component. For example, you can see in the figure A, the shaft has same diameter in all the possible position, but it is not circular. Similarly, in figure B, the rib has same thickness throughout, but it is not flat. Also, in the figure C, you can see that the computer component, the circular shaft, is circular in all cross section, but it is not straight. So, if we take the cross section of this component, we will get the same dimension for this cross section of the all the three component, but they are not all the same, having the geometric tolerances different. So the all the three component of direction are very much important for measuring geometric tolerances. All the above parts are unacceptable if they were checked only for the dimensional variation. Thus here another tolerance comes into picture which controls the shape form of component, that is the geometric tolerance. Thus, geometric tolerance are defined as the maximum permissible overall variation of form or position of a feature. Now, the geometric tolerance are used to specify the required accuracy in controlling the form of component to ensure the correct function position, then interchangeability to facilitate assembly of matching of components. Then the terms used in geometric tolerances are the datum. It is the theoretically exact geometric reference such as axis. We will further see about these terms used in geometric tolerances in the next lecture. Up to this, we will keep for today's lecture. Thank you very much for listening me carefully. Have a nice day.